Okay, yeah, thanks for the introduction. I just want to get my slides up. I just want to note that I'm actually not with Digital Twin Victoria anymore, but I'm still, an active advocate of the work that we've achieved and looking to, communicate. So just so I know the audience, who in here is a developer working on open source libraries? Fantastic. Yeah, sorry. I thought you were just saying you're a developer as well. Okay, great. Who works in 3D? Yeah, fantastic. So, look, a bit of history for myself. I've worked in and around government for the last, 10 or more years, and really looking to drive digitization of platforms and workflows. Originally from more of a solution consultant, but then went back into government. And luckily enough, for the last 3 years, I've been working with Digital Twin Victoria and up until recently. And we had the great opportunity to look at how do we start to digitize regulatory processes, and that being the building approval of the town planning types of permits. And you can start to see on the screen, one of the platforms which we actually built through this, where you could load a 3D model up into a system of a house, into a digital twin of an estate or your building environment, and all of the town planning assessments get checked one by one, and it gives feedback to the designer in order to iterate that design. But that's actually not necessarily what we're here to talk about mostly, even though I'll give a bit of an introduction to it. What we're really looking to share, particularly to the open source community, is we've opened up the framework of how you actually deliver this, and that's called the eComply framework. So the eComply framework is 3 specifications. It's open access. You can access it from the Victorian government website. Just Google eComply framework, QR code as well. And, breaking it down to its core components is 3 things. So firstly, we have a GIS or, a data model, which helps you to build the digital twin of a development site. And I'll talk about how that can be used a little bit further. We have the specifications for the 3D models that you submit into this that really goes beyond a normal BIM classification scheme, more about how you apply town planning concepts inside of 3D models. There's also how you go to assess those models to get the compliance assessment. And it really comes about from the fact that, for the most part, the regulatory processes are paper processes, and as much as they don't really have the filing cabinets anymore in a lot of these offices, for the most part, they are submitted in PDFs, and that actually has an impact on the entire supply chain that actually service those regulatory processes. So just to break it down, you have a designer who's working on a design for a house. They rely on land surveyors to provide information to them. Might be civil contractors, and while they might be sort of working in different tools, they all have to flatten everything down to a PDF to submit it, because that's essentially what the requirements of government are. And really, government are the means to digitise an entire process just by defining the permit controls. But also in the planning space, it's also a very complex world, and it's a very iterative process where things aren't necessarily very transparent. There's a lot of decision making from various people, and realistically, at the moment, it's very rife for solutions to come in and really to enhance this process. But I also just want to note that town planners do a great job, if any town planners in the room, but it's how can we actually aid that whole process just by adding more digital components. Now, I've had a history working around spatial analysis or computation, and I've also worked within a lot of processes where we've digitized processes. Has anyone here heard of ASPEC at all? Put your hand up. So for those who don't know, ASPEC is a suite of data standards, and I've used these quite extensively in my career. I've worked around growth councils where they have a process, and it's tied to permits, where they have a lot of infrastructure which is being developed, and they need to get that data handed across to them so they can put it into asset management systems. And so a company came up with a data specification for different asset classes, whether it's drainage or whether it's buildings, so that the data products being handed across is standardized. And the great thing is when you get standardized data, you can then start to build systems on top of that. The analogy is instead of creating like a hamburger and that taking like 20 minutes, you can actually create the process line. So you can actually do it in 2 minutes and you can get that data flowing through like really quickly. So it's always been a design goal of part of developing our eComply solution. It's not necessarily just the solution, it's also how do we actually fasten up the supply chain. And the other angle of this is the assessment component. Now, open source libraries are out there who have really standardized like the way that we do geoprocessing. And the idea really here was that while we can actually develop these compliance systems, imagine if we could start to create open compliance systems whereby there is, instead of like, standard geoprocessing libraries such as, or processes like buffering or, complex hulls, imagine if we started to have standardized open processes for how does my building assessed like within my envelope, or is the setback correct? Because these are common things which happen every day, like, across the world, and they're not really too different across jurisdictions. And so as we were developing eComply, pretty much from the point where we proved the concept that this was achievable, we had the idea to open up the specifications from the very beginning. And they're open, they're Creative Commons, and they're a template to apply. So, like, we do acknowledge that, planning control is a little bit different from state to state. So it's a good opportunity to use all the learnings which we've undertaken as part of Digital Twin Victoria. So just a quick history on Digital Twin Victoria. It's a program which ran, DTV still exists. However, it was a program which happened from 21 to 24, and it really was a response to COVID. It was about digitising government processes. When everyone had to go home, work from home, there was a lot of investment in trying to make everything a lot more digital. We were able to create a fantastic Terrier.js platform which federated a whole bunch of data to give access. But we also looked at how do we actually streamline a whole range of digital government processes as well. Such as, and we created collaboration forums, gave people opportunity to promote the work that are undertaken across government, enhance regions, their digital uptake, as well as started to get into digital compliance, and we also supported the digitisation of ePlan, which is the subdivision process. But my work stream was work stream 4, so there's eComply, and I've given a little quick introduction. But what we're really looking to do here was, when you're trying to develop statewide digital twins, you go out and you start procuring data, you start building like this statewide data sets, which most of the funding for Digital Twin Victoria went into. But the concept here was how do we actually create a process that would dynamically update? How would you actually have constant streams of new data coming in without having to procure things? And the aim really is to start digitising government processes so all that data starts to stream in. And our aim was to build the first digital twin suburb coming through a development estate which was from a government agency. Ironically though, that got held up in planning, so we couldn't necessarily run with that through its subdivision process. But we did spend about a year developing the solution and trialling this with some really big name building agencies, bespoke architects and building surveyors to test the whole solution to the point where we proved it, and then we were able to commercialise it. And it was a real cross-government initiative, as you can see from some of the planning, building authorities which were our key collaborators. So the types of assessments that the eComply solutions undertake is your typical town planning assessment. How does my proposed building fit on the lot? Are the particular allocations of private open space or permeability, are they accurate measures, as well as how does the light impact our neighbours? Can we look into windows? Sort of similar stuff that you may see GIS solutions do have. However, it's really enhanced by the ability for us to leverage BIM models and understand like the definitions of models and of the objects inside the models. And the reason why this is possible is because even though BIM has been around for about 20 years now, there's this growing cloud capability where we can start to do more and more advanced things inside the cloud and in websites. There's a great side of BIM, which I'm not sure everyone is aware of. It's called computational design, where you can start to render objects and geometry using visual programming languages and programming. It's quite amazing. And the other side of it is that BIM has got to the point where it's not necessarily just big infrastructure projects which are starting to leverage it. You're starting to get your residential builders who want to build from templates, and they get a lot of efficiencies from using BIM. The other great thing is that BIM has really started to embrace openness, because if you think of BIM, you probably think of like Autodesk and you think of Bentley. However, there's a group called Building Smart who've really championed interoperable formats. One called IFC, and that's what we've used in our specifications. But they've also got open source communities, and in fact, there's some really active Australian users inside of that community as well. So just quickly show you through just some of the great things of BIM and eComply services. You can load a model up into the solution. It assesses it, gives you great visual information about where it's compliant or not. You go, okay, cool, I need to actually change that model, bring it back into your authoring software, and there is some open source authoring software. You can use Blender that now supports BIM. You can grab your wall and then just move it. And the great thing there is that everything in a BIM model actually understands like all of the relationships. And so just by moving one wall, it actually changes all the other features as well. It's pretty great. Then you export it out to IFC, and then you can load it back in the system again. And you can see that actually creates like an iterative process that's really, the onus is on the designer. It's not necessarily like submitting a design, having it sit in an email of your assessor, they have a look at it, they go, oh yeah, okay, I need to change that or this, submit it back to the designer. So yeah, it really powers the actual designer. So back to the specifications. So as I acknowledged earlier, it's really about empowering a supply chain here. So our 3 specifications really go through the different phases of how data feeds into a planning assessment. So firstly, we have the land surveyor who goes off and does a site context survey, and this is a requirement of any planning application. They do a feature survey where they go out and measure the cadastral boundaries. They get the buildings on the side. They get maybe get the levels throughout the side. And this is no different to what they do already, but we just want to give them a specification to productize that information, hand it across in digital format, who then hands it to the designer. They load it into their BIM package, and then we help that designer create a particular specification for how do they not only talk about walls and ceilings, but how do they define private open space or permeable areas. Which can then feed into the assessment. And then, of course, we have our assessment practice notes as well, which talks about how do we do the computational assessment for each of the planning rules. So let's break it down a little bit. How do you actually create a data model from a planning rule? So most planning rules is actually about 22 design standards. And let's go through an exercise of actually determining what data entities are within a planning rule. And so these planning rules are the front setbacks. It's how far back from the street can your house be, and it's actually it's a minimum and maximum area. So let's have a look at this rule. So they get broken up into 2 things, what's really related to the site that I'm at, and also what's related to the building. The first one is the front wall. So it's saying the front wall of the Class 1 building must be set back no more than 1.5 metres. Okay, so front wall, that's the first thing which we need to define inside our BIM model. And then also it's saying that in this standard, the street does not include the lane, footway, alley, right-of-way. So there we've got definitions of features around the parcel we need to take into consideration. So as we go through this, we can start to build up all of the different entities within the building design we need to identify, as well as the site data as well. And as we start to go through all those planning rules, we build that up and up and up. So now in the building model, if we're considering site coverage and overlooking, we've got fascias, eaves, gutters, terraces, patios, decks, pergolas, and the roof. So many of those will actually come out of the box inside of BIM. However, we start to think about open space. Within BIM, there's no tag that says open space. So that's where we have to create additional classifications that the designers can leverage. So the first specification to talk to you about is our BIM drafting guidelines. So this is a specification that talks about what formats the eComply solutions select, what level of detail within the BIM models is appropriate, which essentially is it has to have enough information that we can get all of the key entities out of the model, what classifications we support, and that's the BIM specifications using the IFC classification structure, as well as some extensions of that where we say, is a window a habitable window, or is a window screened? There's an additional classification system, as well as particular modelling methodologies. So we can go through an example of that. I've got a BIM model of a house. This is one of the architects who was testing eComply for us provided. And we were mostly looking at townhouses through eComply. And I've got a window selected at the top. And this also is just through a free BIM viewer called BIM Vision that anyone can access and use IFCs. I also, you can do the same thing with Blender and a plugin called Bonsai. But I've got the top window selected, and I'm not sure if you can see that on the screens, but I've highlighted where the classification for that window is IFC window, which is the correct classification. Down the bottom, it's highlighted that we have tagged that as it's a habitable window because it's a bedroom, and it is it screened? And it's like, no, it's not screened. The second specification is our site context guideline. So this is the one where surveyors can, after they do their feature survey of the cadastral boundaries, they can provide the data in a specific format, not too dissimilar from the way that they provide ASPEC data, which they can hand across to build the digital twin. So in this case, we're looking at the cadastral boundaries, but it also includes the planning information, like what particular restrictions or covenants are on the site, elevation, neighbouring houses, and what are the land use interfaces around the lot. And there's just another example of providing all of the elevation model. And we can go through an example of this. So this is the digital twin of the site. We've got our shapefile, which is providing our cadastral boundaries, and those are broken up into individual interface sides, whereby we can note that on the rear it's facing like a laneway, the front I think it's a park, and on the sides it's facing two different housing lots. And all of those come in and will actually impact the way that the modelling is impacted, and the different elements as part of the planning rule. So finally, we've got the practice note, all the assessments, all the computational assessments. And the code that we actually used as part of eComply was called the Small Lot Housing Code, which was primarily to develop townhouses through growth regions, and it had 22 different design standards, whereby it looked at things, like the setbacks, the overlooking, the site coverage. And the interesting thing is that when you actually broke it down, a lot of those design standards had multiple different checks. So there was more than 90 checks, which we were able to assess in about 90 seconds, including the loading time of the BIM model, which is quite efficient. But these design standards, you'll actually find there's a lot of synergies, like across jurisdictions. Like I didn't check like Hobart City Council, but you'll find that they will determine like the setback. Generally it's like the average between like your neighbouring properties or a particular amount. Yeah, so they are like a template which we can apply to other jurisdictions. And each one is structured in a standard structure whereby we talk about the rule. What is the actual rule for that check in the design standard? And is there any particular digital interpretations we need to make? Because sometimes the rules are a little bit open and we need to make it consistent. Second, well, how do we actually interpret that? What's the methodology to interpret that? And finally, we talk what data from the site context and the BIM, the building model, do we need to consider as part of that assessment? Whether that's explicitly in the model or we explicitly need to exclude it from the model. And finally, the computational assessment methodologies. And these are very, BIM computational design concepts. However, they do somewhat apply to spatial geoprocessing as well. First one is modelling envelopes, and generally that's an area like where you can have a feature reside or exclude. Then we have clash detection, which is quite similar to a spatial intersection, just in 3D. That's very sort of BIM talk for a spatial intersection. Ray tracing, which is the movement of light, and of course just selecting features and then measuring those. Okay, finally the call to action. I specifically wanted to come out to the FOSS4G community to promote these specifications because as part of DTV we were given license to start to innovate and drive the digitisation of processes, but we don't necessarily see one platform doing this for an entire jurisdiction. It's really, the time is really great right now to get into the prop tech space and start to develop solutions. This is a great way to learn from what we've done, either from a software development perspective, or from if you're a land surveyor and want to start to productize particular your surveys to feed into the upcoming digitisation of the planning sector. And also for policymakers, it's good to think about that ASPEC example of how, by enforcing standards and particular digital acceptance for permits, you can really start to drive efficiencies through your system and get great data handover. And the final one is that, if you do take this up, which I really commend you if you do, is that let the Digital Twin Victoria team know the program itself has come to an end. However, they're still tracking, they're looking to develop the next business case. And that's really where the second round of investment will come, and all of the data they can get about people leveraging the products that they've left behind after the first round of funding will help. So, yeah, it'll be fantastic if you could. Thanks all, and open for questions.
Round of applause for Luke, please. Questions for Luke?
Hi, firstly, a great talk, and it's actually quite exciting work you're doing, in my opinion. I work on a regulatory project in WA at the moment, which is connected to mining regulation, which is kind of related to what you're doing in a way.
Yeah, great.
We do a taxonomy of mining activities that are put through a rules engine similar to the kind of thing you're doing, and I've been thinking for ages that what we do should be based on at least some kind of open system for validating data, spatial data, against a set of rules. With the computational analysis that you do on the BIM data, do you actually kind of specify any of the rules declaratively, or do you build custom logic for each rule that you have to administer?
We had a partner develop the solutions, which we developed specifications from, and I believe that was more so Yeah, I've seen examples like where the user can actually start to build the rules that are going to be assessed against. So it's more of like I guess the full suite, like where you'd want to start to configure for different use cases.
Our rules are much simpler. So it's stuff like, a campsite can't be within 50 metres of a river or something like that. It's not we don't have to do any ray tracing or anything like that. And I've kind of been thinking, well, why isn't there a sort of extension to JSON schema or something that lets us just say this is how it is? But yeah.
Yeah, I think that would be great. I think ultimately the rules-based systems is going to proliferate, and I can see that requiring like a lot more sort of configurability. As part of the solution we've developed to date, has been more about just proving this can exist and allowing more of a commercialized solution, which is a bit more refined in like what you can deliver, just to make it less, I guess, like technical, I suppose.
Do you guys promote this in the planning world a lot?
Yep. So we've talked to the PIA and also places like the UDIA, etc. So essentially, the last 3 years of my life have, as much as it's been a technical project, it's been more of like a change management and communications project to really, which I think is inherent in part of innovation really. Otherwise, like you're just developing software for the sake of it.
For sure. It's also really political software. It's not just,
Oh,
people care what gets approved. So it's like...
Yeah. Well, the PIA recently started to release a response to the AI in town planning. They released a paper on it, which talked about the impacts of rules-based systems as well as the generative systems and how to guide councils whether or not to, what they support, what they don't support. And luckily, they're very big on like openness and ensuring things aren't necessarily always black boxes, that, there's some reason for decisions being made, and that's by opening up our specifications, that's ultimately like what we want to do is reduce the black box factor of these digital solutions, which kind of scares people, really.
Thank you very much for the questions. Another round of applause for Luke, please.
Thank you.